Okay, girls, so substitution is a very important factor to integrate, and it's very, very important that you know it very well. So today we're gonna complete the exercises 27, 28, and 29. Please pay attention and don't fall asleep. We know this is kind of boring at first, but believe us, when you get it, you're going to love it. At the end of this stream, you'll know everything about the problem your teacher is explaining and you're not listening to. So wait up. Do you know what integration is, first of all? Integration is a way of adding slices to find the whole. It can be used to find areas, volumes, central points, and many other useful things. Okay, so the problem is, calculate the area between f of x, the x-axis, and the vertical lines x equals 0 and x equals 10. So, how to solve this? We're gonna go in easy steps.
As you can see in the graph, the original function is shown in a green color, as well as the area between x equals 0 and x equals 10, which are shown in a yellow color.
To complete our project, we had to draw an approximation rectangle and label its weight and width. In integral calculus, the rectangle method is an approximation to a definite integral, made by finding the area of a group of rectangles whose heights are determined by the values of the function. We decided to draw 10 rectangles with a width of 1. The values of f of x were obtained by substituting our values of x in the function, having as a result the height of each rectangle.
So the next step is to integrate the function, and we cannot do it with the basic techniques. That's why we're going to use the substitution method, which uses the variables u and du. That's going to get us 3 over 2 logarithm of x squared plus 4 plus c.
To calculate the area of the region between x equals 0 and x equals 10, we used the first theorem of calculus, which consisted on substituting the values of 0 and 10 in the x variable of the integration result and subtracting them. Our result for the given area is 4.8870.
So just for a summary, what we did was to apply the integration method of substitution to the f of x. We calculated the area of the region between x equals 0 and x equals 10, and with the theorem of calculus, which we got by substituting and subtracting.
After solving our given problem using the substitution method and figuring out how to obtain the area under a curve, we can conclude that this project also helped us to understand how these type of problems are applied in real-life situations. There are a lot of applications in fields like physics, engineering, programming, and chemistry. For example, you can graph the speed and the area under the curve represents the distance traveled. The answer is 4.8870.
You're right, Katia. Thank you so much.